we go. Wait a minute. You know, when you're running late and things just get later instead of getting better, it's my life. I am so sorry, you guys. I am so very sorry. And I'm not even ready, but that's okay. Yeah, there we go. Happy Wednesday. Okay. Screen one, share. Okay. So what do I want to do? That is not what I want to do. Yeah, we're going to go ahead and clear. We're going to kind of start from the beginning. Okay, like I said, when you're running late and things just get later, that's kind of what's been going on. Okay, so I'm going to pick up kind of where we left off. Now, because I did clear the kernel and redo some of the redoing my testing and structure and all that stuff, um, the numbers that we get today might be slightly different than what we got on Monday. Don't panic. It's probably just that the test and the train sets are different than they were before. So we're not going to stress over those little minute issues. Okay, so we went through the multi-element, we did the single element model, and we did it on phones per 1,000. And we're trying to create a model to predict the gross data product. No, gross domestic product. That's it, words. The gross domestic product. So we had an R squared that came out to be 0.74-ish. At least this time I ran it. Can't remember what it was last time. Then we went and we expanded it from the single element to a double element. And I added net migration. You can pick whatever one you want. That gave me some additional coefficients. And see here, you can see here how like some of the old ones were very different. Because my intercept's like 1140 now. Okay, so then we did the R squared on it. Oh, it is slightly different because I remember last time it was like 0.7, it was like rounding up to 0.73, and then when we did the other one, it was like 73 something. So this one's a little different. So 0.79 or 0.80. Here, the whole basic purpose of this is that when we add additional elements into our model, our R squared should be greater than the single. And as we're getting closer to one, so we're almost at 0.8. So that's actually pretty good. We ran it this time, it got a little better. Again, it just depends on what you choose for your test and what you choose for your train. We did go through the logistic regression. So here, I'm going to go ahead and run that one. And then we created our model. We took two random things. We got random coefficients for this ugly equation. Here we've got our accuracy, precision, recall, F1. Um, and then I think we finished up going through creating two baselines, one that was completely random. So we just went with the random and then we went for most common where everything was zero. So we put everything to kind of one side. And we got the little warning, but that's okay because these are zeros. Okay, so my accuracy was 0.4. Ooh, that's a much worse accuracy than we had last time, wasn't it? My precision is 6%. Recall 50/50 and 11.7 for F1. Here, most common. Now when I dumped everything as a zero instead of the zeros and ones, I got a 93%-ish. Okay. And that is kind of where we stopped. Any questions about what we kind of looked at? Yeah, I know. I'll talk to you in a second, Narik. All right, as soon as we're done. I believe I wasn't able to access, but we'll talk about it when we're done. We're not stressing. We're getting to the end. We don't stress. We don't stress at the end. I know it's like when you want to stress, right? But we're not going to stress at the end. Okay. Questions, comments, concerns, insults. Wait until the end. We want to wait to the end. Okay. Okay. So I did get a lot of good comments from you guys about um, working through it this way. I wish we'd kind of figured that out earlier, but that's okay. It's okay. Um, okay. Clustering. Okay, so since we're going to take the same data set and we're going to try to cluster it, what we want to do is we want to take our data and make sure it's what we want. Okay, so we can do that. Um, and we need to make sure that it's scaled the way we want it to. So remember, we've got the countries, we've got all these different things for our countries, right? Population, area, density, coastline. So we want to kind of take a look at it to see what we can do. So if I say first, let's see, let's purely numerical. So numerical is going to be equal to countries drop. Okay, let's take a look at this. So region is not numerical. That looks to be everything. So let's get rid of region. Okay. And what I can do here is my axis equals 1 is giving it to columns. It defaults to rows. We don't want rows, we want columns. So let's create a data frame here that is going to remove the non-numeric data, which is the region. Okay, so that's what I did first. Then let's take a look at the scaling. So here in the sklearn section, there is something called a pre-processing that you can do, which is going to help you for the scaling, centering, normalization, normalization. I guess that's a word. Binarization, that's not a word, but um, and I'm going to use the transform the features by scaling each feature to a given range. So we're going to use this min-max scaler. Okay, so class sklearn.preprocessing min-max scaler, and then we're going to send it a few things in order to do the scaling itself. Okay, so my scaled, oops, click, my scaled countries is going to be equal to, okay, and we want it to be a data frame. So pandas, oops, does dot data frame sklearn pre-processing, okay, min max scalar. Okay. And then we're going to say fit transform. Columns. I'm trying to figure out if I'm supposed to put another uh, parenthesis there. Let's see, fit. See also fit. Yes. Okay, there we go. Columns equals. And what I want it to be is the columns in the numerical data set, right? So numerical dot columns values. Oops, that is not how you spell that. Okay, that makes sense, kind of hope. And then index equals, that's not, why can't I find the equal sign? There we go. Numerical dot index values. Pretty sure that's what I wanted to say. See if that does what I want it to do. Yeah. In cell 7. Oh, I know what I didn't do. I didn't turn on my, here we go. Hello. There we go. Pre-processing, fit transfer. What am I doing wrong? Let me think. Hold on. Let me pull up my other one. Oops. Okay, let's see. Home. Because I did it before. Let's see. I'm missing a parenthesis, I'm sure. Let's see. There we go. In max scalar. Oh, numerical. Oh my goodness. ICAL index equals numerical. Index comes first. Index equals numerical values. Index values, and then columns comes next. Sorry, numerical columns. Oops, UMN values. Okay. Columns equals. Oh, index values, because that's supposed to be a comma. Sometimes it's hard being me. What did I do? Data frame has no index values. Index equals numerical dot index. Oh, because the dot goes there. It's like my brain knows that there's supposed to be a dot in there. I just put it in the wrong spot. Okay. So that's going to scale everything down from this one here. So this line 3 took care of getting rid of everything that was non-numerical. Line 5 is going to use this max scalar and do a fit. So it's going to compute the minimum maximum to be used for the scaling. And so then my index is going to be the index values and my column is going to be the column values. That's basically what we're doing. Okay. Okay. Generate a plot to help you pick. That's supposed to say pick. To help you pick. Here we go. An appropriate number of clusters. Okay. So we've got num clusters equals, and we're just going to give it a list. Okay. Now, what we can do is we're going to go through and we're going to loop through. So for num in range 121, num clusters, append, because we're adding to it, right? sk learn cluster. Oh, I also brought this one up. This one was the drop, the data frame drop. sklearn, let's see if I can find the cluster one. There it is. There's the cluster. And then we're going to do the K. The K means clustering. Okay. Okay, cluster dot K means n clusters equals num fit scaled countries score scaled countries. Okay, and then let's plot that. So matplotlib PyPlot, plot num clusters. Okay, let's see what happens. So remember, this should give us that kind of like arched shape that is going to help us determine which number we should choose. Okay, we got some warnings. That's fine. But see, there's my kind of plot. We talked about kind of where the bend is, kind of picking the number of bins. Okay, so for here, two is not going to be enough. Where's it kind of right here? It's kind of starting to get much more flat. So what if we choose something like 10-ish, 10, 11, somewhere in there. Okay, because see how before it's got a lot of increasing going on, and then from this 10 point on to the right, it's pretty flat. So let's choose 10. Okay. And again, the warnings are fine. It's not doing anything bad. Okay. So number of clusters equals 10. And I'm going to do it putting a variable in here because that way you can change this number and kind of see how things go. Now, remember the number of clusters, even though here we've got 2.5, 7.5, needs to be a whole number because I can't do a half a cluster. So let's do 10. So then countries, cluster num, right? Because right here I created an additional column and I'm calling it what cluster number that data that row belongs to, right? Equals sklearn cluster k-means and clusters equals number clusters. Okay, and then fit scaled countries. And we're going to add it to labels. Okay. Now what did I do? Scaled countries. Okay, where am I missing my parenthesis? Oh, right there. How do I know that's always means it missed a parenthesis? There we go. Warning is fine. Okay. Turn my page. Okay. So now let's go back up here. I lied. Let's plot first. We're gonna plot first. So matplot lib pyplot bar. Okay. X or X in range number clusters, countries, group by. We want to make sure that they're going to be all in the same group for the cluster. Cluster num count. Okay. Pop, oops, population values. Uh-oh. I think my typing's worse today than it was Monday. Values. And this should dun, 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 give us a nice pretty bar graph. Okay, so what it's graphing is the population of each of basically the clusters, okay? So cluster 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so down here it's just the cluster number, and we're plotting some values that are in it. Okay, because remember, we're putting them in clusters. It would be pretty cool to change the bar graphs and kind of maybe change it to a scatter plot and group them by that and kind of see where the things are lying on your axis to see if you can visualize where the clusters are. That would be kind of cool too. Only I think this would be cool, right? Okay, so generate some statistics for each cluster. So we can use our describe. So countries group by the cluster number, right? Describe, include, mean. Okay, let's see. Good Lord. Why am I so bad at this today? Countries dot group by cluster num. Describe, include equals mean. Hmm. Okay, what are your thoughts? What did I do wrong? Countries group by cluster underscore num dot describe. Include mean. Include name. Maybe that's not what I meant to do. Oh, wait, I know what it was. Let's just try describe. There we go. I'll just do describe. So what this is giving you is grouped by cluster. Okay. So these are grouped by cluster. The count, the mean, the standard deviation, the population, the max, the count of them, the area. Let's see what else is over here. All of the different values, it's got them marching across. Okay. So I can also make it a little bit prettier, okay, by if I say, let's try this. Let's try that one. There we go. So it's giving the mean of each of these values only in the numeric columns, but it should all be, well, we're back into countries, the original one. The original one doesn't have. Okay. So here, cluster 0 has a mean population, a mean area square mileage, population density, blah, 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 blah. Okay, so that's giving us a lot of information just on the cluster. Okay, well, if I need to find out what is in that cluster, I can do something like this, right? So I'm going to choose cluster number 6. Let's go choose this one right here. Okay, and let's see, cluster 6 is right here. 0, 1, 2, 3, 4, 5, 6, 7, 8. Maybe we should pick 8 because it's kind of small. Let's see what 8 does. Okay, let's hit that one. Ooh, look at that. So cluster number 8 only has two countries in it, China and India. Interesting. Interesting, right? That's this little short one right here. Okay, so what it does is it's going to show you what rows out of the original data set is in that cluster. So let's pick another one. Let's pick the big tall one. So 0, 1, 2, 3. This is 4. So let's look at number 4 now and see what countries are in that one. Okay, I have a lot more countries this time. And some of them I can't even pronounce. Argentina, Belize, Brazil, Chile, Colombia, Costa Rica, Ecuador, Estonia, Fiji, Georgia, Jordan, Mexico, Panama, Peru, St. Lucia, Uruguay, Venezuela. Okay. So the last question on this is to do your best to interpret what these categories are meaning. And it could be helpful to see what countries are in there. So if you come back up, what did we look at for the clustering, right? So here, right, we looked at population, right? So let's go back up here real quick. And actually, I lied. I'm gonna go down here. Try to find the number of clusters there. So say I pick 12. I can change that here. I can run that one. Okay, I've now more bins, more clusters. So now I've divided up into 12 clusters. Notice they're not as the same, we don't have that one that was real little anymore. Okay, so there is my statistical information about my clusters. But let's go ahead and look at cluster number 9 out here. Let's see who's in 9. Aruba, Bermuda, Cayman Islands, Finland, Hong Kong, Iceland, Japan. Oh, the US. Okay. Now this cluster is the one that's out here. Okay. Again, you can find some populations, areas, densities, coastline, based on the cluster and how it's clustered. Does that make sense? Did that help again as well? Okay, what questions do we have on the clustering and the regression stuff? What questions do we have?
Do you mind posting this video right after class? Because I'm trying to follow the video and not like go back to my thing the whole time.
Yeah.
And I
Um,
don't want to like wait until I don't remember, if that makes sense.
yeah. Yeah, what happened was when I'm gonna stop the video. Um